Okay, let's start the afternoon keynote speech by Yukie Koyama. It's already time, so without a wrong introduction, I'll start the presentation right now. Please, go ahead.
Okay, thank you very much for introduction. And thank you very much for coming to my presentation today. It's great honor for me to give presentation like this to be given the opportunity to talk to you, the leaders of CAT area from all over the world like this. And I'm really excited, but at the same time, I'm nervous. So when I make mistakes in many places, well, please help me. Okay, my title is Computerized Adaptive Testing in English for Specific Purposes, as you can see. And I'd like to just add subtitle to this title, main title, focusing on small-scale in-house CAT for your classroom students. And that's my point. One of the points that I would like to focus on this presentation. And before I start anything, I would like to give just a brief introduction of myself. Well, this is a picture of Plato and Aristotle. I was born in Tokyo, and I moved to Kyoto as a graduate student, and my major was Western philosophy, especially classical philosophy. So I was conducting research, and especially in Aristotle. And as you might know already, the left-hand side person is, with red clothes, is a Plato who's pointing the heaven. And he says that we should think about ideal stuff in our life. And the person on the right-hand side is Aristotle, and with blue, maybe blue clothes, and he's pointing, well, we can't really see it, but downward. And he is more realistic, and he was, he was writing about nature and so on, but at the same time, he was writing about metaphysical, the big, important book, Metaphysics. Anyway, I started become more interested in the earth or in the nature these days after my retirement last year. So I think his teaching, his way of thinking probably gave me some insight for the love of the nature. Anyway, I went to University of Illinois to study teaching English as a second language after a long winding road, and then I became an English teacher at the University of Technology at two places, one in Nagaoka, and Nagaoka is a part of, it's in the southern part, well, in the middle of Niigata Prefecture, and it's in the, rather mountainside. So we have a lot of snow there, and I spent 5 years in Nagaoka City. So I had several chances to come over to Niigata, but not in winter, not in summertime like this. The weather was not so nice because it was in the middle of winter. But I was surprised to see that Niigata area doesn't have much snow, because in the same prefecture, Nagaoka has much more snow, like 2-meter high sometimes. Anyway, I went to Nagoya to teach at another University of Technology. And teaching at two universities of technology has affected, influenced me in many ways of my research and teaching style and so on. Well, I have to tell that when I was in the United States as a graduate student of University of Illinois, that was from 91 to 93, and it was a golden time for the Chicago Bulls. if you are a basketball, lover, then you might know, of course, Michael Jordan, and he was superstar like that. Anyway, here is an outline of my today's talk. And first, I would like to mention just a little bit of CATs for language learning, because I learned that many of you are from different backgrounds. So I usually give speech or give presentations at language learning areas, at language learning conferences. So it is my, new experience to give talk at this kind of conference in which all the attendants are from all different fields. Okay, number 2, English for specific purposes. Because of that, probably it might be better to give you a little bit of information of English for specific purposes. And then content validity issue of related to CAT. And number 4, development of an ESP CAT. And number 5, psychological aspects of CAT, and summary. At the beginning of my presentation, I have to tell that Professor Kimura over there has been working very hard with me, and we have had very good collaborative research in many researches. So I would like to just appreciate him a lot. And more than half of my talk owes him. So if you have very specific questions, it might be better for you to ask him directly. Anyway, CATs for language learning. Dunkel says that in the late 1980s, they already studied CAT in the language learning areas, and in-house researchers in foreign language education at the Defense Language Institute, at universities throughout the United States, Britain, and Netherlands, etc., started to conduct research in CAT already. So it's almost, it's more than 30 years. And so with the history of CAT in general, language learning area CAT started almost at the same time. Number 2, English for specific purposes. This is usually called ESP, as opposed to EGP, English for general purposes, sometimes. And it is focused as one of the most appropriate methodology to teach English efficiently to, not only students, but also, people who are doing their special work at special places. And needs analysis is a very important key factor for the ESP, for the successful ESP. 1970s, ESP text analysis started, and many researchers started analysis on the text areas. So which leads to corpus analysis later. And Hutchinson and Waters, 1987, says, ESP is an approach to language teaching in which all decisions as to content and method are based on the learner's reason for learning. So learner's reason for learning means why they have to learn this and for what. What's the goal and why they would like to learn this, and so on. So, and another definition given by Dudley Evans and St. John, 1998, is something like this. They give two different categories of the ESP. One is characteristics. One is absolute, and another is valuable characteristics. And in the absolute characteristics, there are two parts. One is ESP is defined to meet specific needs of the learner, and the second, ESP makes use of underlying methodology and activities of the discipline it serves. So ESP is not the theoretical, theoretical thing, but also it includes all the activities and then methodologies and curriculums and so on. Okay, so needs analysis is a key, as I said, for ESP, and teaching and material development are on the basis of needs analysis. Well, should be on the basis of needs analysis. We usually don't do, needs analysis, and without doing that, we just jump in the curriculum development and so on. That is very, very usual in, some parts of the universities and high schools and so on. Okay, I conducted a needs analysis once at the University of Technology, and the subjects are, I gave a questionnaire to alumni members and professors at university and students, graduate students. And these are the results. I probably don't have enough time to explain one by one, but summary is like this. Well, there are differences in the order of importance depending on the member of the university. Alumni members think that reading is the most important. Well, it's, alumni members, engineering teachers, graduate students, all of them agree with the point that reading is the most important skill for them out of 4 skills. Reading, reading, reading. Reading comes first when you talk about importance. But it's different if you talk about, subjects, subjective side. So what do you think you lack? And to this question, they think that alumni members who are in workplaces, we chose many different generations, and they answered they lack listening skills and speaking skills most. Listening skills most, and students also think they lack speaking skills and listening skills. These B's stand for basics. So students, engineering teachers, professors think that students need more basics. They even don't have basic knowledge of English. That's what they think. Okay, and summary of the needs analysis is something like this. Number 1, reading is the most important skill for all the groups. And number 2, alumni members think that listening and speaking should be taught at a university more than other skills. And number 3, alumni members and students perceive they lack speaking and listening ability. And students think they lack writing ability also. And what alumni members and students think important is different from what they think they lack or want. So depending on the members of the certain areas, the perception is different. So this is the perception side, but in the needs analysis, you of course have objective kind of analysis, such as text analysis or more interview type of needs analysis. Many different types of needs analysis should be conducted before you decide what to teach and how to teach. Okay, number 3, content validity issue. Okay, based on the need analysis, we found that the reading is the most important. So vocabulary is one of the key factors to raise, to enhance reading ability. So vocabulary knowledge should be the target of the measurement. That's what we thought. So development of a CAT system for engineering students to build and measure their vocabulary knowledge was started. Well, of course, there are some other reasons too, practical reasons for listening and for reading of long passage. Well, to start the development first, for the first time for us, they are too, complicated for us to, begin. So we started doing it with vocabulary items. Advantages of CAT, well, needless to say, you all know these things already, but I just, repeat it once more. Individuality and time independence, and eliminating test items of inappropriate difficulty, and saving testing time, and so on. So these are referred by Brown, Wise, Kingsley, and of course, many other researchers. And in addition, since I was teaching at the University of Technology, engineering students are good at using computers. So that's why, that's one of the factors that we decided to start the development of computer adaptive testing at that time. Okay, there are some problems of validity and individuality. Different items are given depending on the test taker's responses. That means, examining content validity of one test, one whole test, is not so simple. Of course, if you have, unidimensionality of the whole test, then you probably think, we don't have to worry about it. But from, I don't know, some article also mentioned that experts' eyes are needed to check all the items in the target domain, especially for the ESP test. So content validity, if you talk about the content validity, Barker 2008 says to evaluate whether a test has sufficient content validity for a given purpose would be the analysis by subject domain experts of the relationship between the test content and intended learning outcomes. So it is crucial for us to check each item, to make it sure each item belongs to the certain domain that you're trying to focus on. And, well, I just skipped this. And Steinberg et al., 1990, says item selection procedures that ensure a balance of item content across every level of proficiency facilitate meeting the content specification for a test. So this means that we need to have a balanced item bank in terms of content and, of course, in terms of difficulty. Okay, and we started to, focus on corpus about, let's say, 15 years ago or more than that, 20 years ago maybe. Text analysis in needs analysis is, well, analyzing the target language text that the learner has to produce or to understand. So we compiled several kinds of corpora first. That is not only for the CAT development, but also in order to find out the well, characteristics and some specific, well, general tendencies of engineering, for example, academic papers in the engineering field, and some other articles in the engineering field. So that's what, as I said, about 20 years ago, I started compiling all the corpora. And, well, writing test items based on the analysis of science and technology corpora of different levels ensures building an item bank with sufficient validity. So that's how we start using corpora for writing items. Okay, development of an ESP-CAT. First, I'll explain a little bit more about lexical items we developed for this CAT. We extracted keywords and phrases based on the analysis of science and technology corpora. Well, it turned out to be 100-word items and 80 phrase items and 61 word items. And word items are extracted first from Scientific American. Well, the size is 830,000 words. And the procedure is something like this. Target top 280 words and so on. And we wrote 50 Japanese English type and 50 English Japanese type items. And for the key phrases, we extracted 4 grams and 5 grams, well, most frequent 4 grams and 5 grams from 4 different corpora. That's applied physics and bioengineering and electrical engineering and mechanical engineering corpora. So they are representative of, they are well, frequently used phrases in these corpora. And later on, well, after conducting the first CAT, we found that we needed more, well, easier items for the students because the distribution was not so good. So we conducted another, well, we wrote another group of items, which was based on high school textbook of the United States, biology, physics, and chemistry. And we chose high-frequency words from these corpora. Okay, well, these are top 10 words of each corpus of high school textbooks. Okay, there are several types of items. The first one is something like this, sentence completion type. So you choose the most appropriate word from the choices, and that's one type. So the sentence itself is chosen from the corpus, but modified and a little bit, you know, we changed some parts in order to fit in the students' ability of English and make it short. And this is another type, sentence completion, new type. And Japanese English type. So we show Japanese word, and they select one of these English words. This is opposite from English to Japanese. And this is English to Japanese, but we give sentence and they find the meaning of the underlined word. Okay, so this is the summary of items. 100 items of word extracted from Scientific American, and 100 items and 80 items sentence completion type. This is phrase from academic journals for engineering fields, and 61 items mixed format and from high school textbooks. And this is only word type. Okay, and we conducted CAT, well, actually several times, but the one I'd like to show is this. We conducted this CAT in 2015, and the red parts are additional items. These are high school, extracted from high school textbooks. So before that, I mean, still distribution is not so good, as you can see. Okay, this is the result. This is item distribution, and this is estimation. And if you make it overlap, it looks fine, but actually we set the probability at 80% to make it easier, for the students. So actual distribution of the estimation is should be like this. And the problem is, well, these are the red dots shows exposure to the items, and items of this area has so much exposure. So that means we needed more item of this difficulty, this area. So these items are something that which were not used so much, answered so much. Okay, correlation coefficient between CAT result and pretest result overall is 0.68. Not so bad. But this is a summary of our CAT implementation. These results showed the construction and implementation of a small-scale in-house CAT using ESP Corpora were relatively successful. However, although the overall validity of the CAT was ensured, we need more items to improve the difficulty balance. It is clear. So we still need, we are actually still, we're planning to write more items for this CAT. Okay, number 5, psychological aspects of CAT. Well, target probability and students' perception is one thing which we focused. As you know, usually every student tends to get 50% correct in CAT because such items, they maximize text information, test information for each student, of course. But as you can see, well, even students with advanced, level, in advanced level, who usually get very good score in pencil and paper test answer only 50% correctly. That's natural for the cat. So they think that they didn't perform well in the test. So we conducted survey. Did you feel the cat easy or difficult? To this question, this was a survey done by Kimura, Dr. Kimura and Nagaoka, Dr. Nagaoka in 2011. They found that nearly 50%, more than 50% of the students perceive CAT was very difficult. And in total, more than 90% of the students perceive that CAT is either very difficult or a little difficult. So very negative feeling about that. And how about this question? Did you feel discouraged? Did you feel discouraged or unsatisfied with the experience? And about 60% of the students answered discouraged. And only, less than 20% were satisfied, according to this survey. Okay. So when the target probability is set at 50%, CATs appear to be very difficult for most of the students. And the experience of taking a CAT discourages students mostly. So they have a negative feeling, negative backwash effects. And in the end, maybe there are loss of self-confidence, loss of self-efficacy, and loss of motivation. This might be the result of this experience of CAT. Okay, and we set 5 different types of CAT with different target probability, like this. The first one, CAT A, is very ordinary type of CAT, 50%, where they feel it's difficult but short, 16 items. And the second one, CAT B, has more items, longer but easier. Well, the probability is set at 80%. And CAT C, easy at the beginning and difficult in the end. CAT D, difficult at the beginning and easier in the end. CAT E, easy at both beginning and end. So in the middle, you have a usual CAT items. Okay, the result is like this. And test taker's reaction is, the people who took easy but longer CAT B, answered the CAT was easy or just right difficulty for them. Okay, easy but longer CAT. CAT B, people who took this type of CAT, more students felt easy or right level, and less students felt difficult. Okay, the number of students who said it was very difficult is smaller than other 3 types of CAT. In this type, this number is a little smaller than this. So our next question is test taker's reaction about happiness. Cat A, Cat B, Cat C, Cat D, Cat D, Cat E, these are the same order. And as you can see, happy part. Easy, longer cat is Cat B. So people who took this cat answered, they were happy. And the number of students who answered sad is smaller than other cats. Okay, students feeling easy, but people who took easy but long cat B, more students felt happy and less felt sad. And difficult at the beginning, cat D is a little peculiar. Well, I don't know what to say, but they are sad. More students answered sad after this experience. And a very small number of people are, this is a limited number of students said happy. So D is something difficult at the beginning. Difficult at the beginning, easier at the end. So we imagine that before doing this survey, if the ending is easier, then people might become happier. But actually, this turned out to be opposite. So we need more research on this area, of course. The number is very much limited. Okay, so test takers' psychological tendency. No matter what type of cat the students took, majority of them answered they prefer easy cat even if it is longer. All right, summary. Small-scale in-house cat using corpora of the relevant domain to suit a given ESP setting was introduced. CAT has many advantages and potentials, of course, but the students' general perception of taking CAT is not so encouraging. So maybe we sometimes have to ask ourselves, what is a test for, turning to the very beginning of the, this test thing. And a test is to give more information to the learner. A test is to give appropriate diagnosis of the learner. And test is to, finally, to support and encourage the learner. So we need to focus more on the formative type of assessment, and which lead to deep learning of the students. And one point is that I would like to focus on dynamic assessment as the next stage for us. Of course, dynamic assessment started with Vygotsky's theory of the assessment, but assessment and teaching not as a distinct activities, but as dialectically fused. So teaching and assessment should be more closely related, and we need to consider these suggestions. And future implication. Well, small-scale in-house cats in a classroom, in contrast with large-scale standardized cats, could be more supportive for learners to deepen their learning. However, learners need appropriate mediation, help, or hints to enhance their ability in practice. So computerized dynamic assessment should be focused, as a next stage for us. That's the end of my presentation. Thank you so much.
Thank you very much. And we are running out of time, and from 1:30, the power session will start downstairs. So just 1 or 2 small questions we can accept from the wall. Please raise your hand.
Thank you. It was a pleasure to listen to. I have one question. I don't know how you test this scored, but since it's a CAT, making the test easier might have the paradoxical result that a student is delighted during the test because the questions are easy, think he or she is doing a great job, and then get a score which is deeply frustrating because it's a low score.
And your question was?
Is this something you have been observing?
Yes, yeah, that's one thing. And students with higher ability, well, even if they get the good score as a result, but the experience itself is not so happy one. That's what I wanted to focus.
Okay, let me close this session. Thank you very much, Professor.
Thank you. And in the next session, well, Dr. Sumi will talk about dynamic computerized testing related talk.
Okay, welcome everyone to the last session of the afternoon before the wonderful dinner we're going to have tonight. So I'm Mark Reckase. I'm the organizer. This is symposium number 1. And so I'm just going to give a brief overview and then get into one of the papers. I have sort of some unhappy news that 2 of the presenters for our symposium are having issues with U.S. immigration. And they were worried about getting out of the country and then coming back, in again. So they've recruited us. I'm a co-author on this paper, so I'm going to present Emory's paper. And we have another volunteer. She down here is going to present the last of the papers. So we've had to have people fill in for the persons because of, let's say, embarrassing things with the U.S. government. So I'll kind of, I think this is kind of crazy because I know that Zui Chen was applied for, this 3 months ago, and it's been taking forever, and she wasn't able to go over and do this. Okay, what this session is about, to get into this so I don't take up too much time, I'm just going to make a few introductory remarks, and then I'm going to turn into Emory over here instead. But the purpose of this session is to deal with the issues of item pools. I think everybody in this group, they're all sophisticated users of computerized adaptive testing, know that you could have the best algorithm in the world and wonderful procedures overall in terms of estimation and everything else, but if you have a terrible item pool, that your procedure still won't work very well. So that the item pool that is used for an adaptive test is critical to its use. So the idea of this symposium is to talk about issues related to how item pools are organized or structured and how to evaluate the quality of them and issues that are related to producing a good item pool. And so we have 4 papers that are going to be about that, and each one of the presenters have about 20 minutes to go over and present the results, and then there'll be time for questions, and I hope that you'll have plenty of those. So that's my introductory comments. So that's the first part of the agenda. And I'm now going to actually turn into Emory. This is really his paper, and I always have trouble mispronouncing his name, or I have trouble pronouncing his name. I can mispronounce it very well, but I think it's something like Gonolatish. So anybody who is Turkish could tell me how to pronounce this properly. I've been working on it for years, and I never get it right. So I usually just call him Emory. So it's kind of to get around the problem. But this is really his work, but I did work with him. We talked about this problem a number of times, and the problem is that he wants to address is if you do have an item pool for a computerized adaptive test, how do you tell if it's good enough, if there's any problems with the item pool that you have? So he'd worked out procedures, and this is his work. This is not mine, although I agree with the approach that he's taking, and we've talked about this a lot. So I want to make sure he gets credit for it. He's now actually, he's listed differently in the program. He's now at Columbia University in New York, where he's got I think a temporary appointment to be teaching there, and I hope he gets to stay afterwards. But he's moved from where he'd been before. So let me get into this a little bit. Okay, what we're talking about, this is his overview. These are his slides. All cats have item pools, so we'll talk a little bit about the item pools and cats. And then he has created something which he calls the Item Pool Utilization Index, and he abbreviated IPUI. And I've actually been trying to tell him that he needs to change the name of it, because if you pronounce IPUI, it sounds terrible. So he needs to find something that sounds better when you pronounce it. And he'll have an example of this and show some results on the uses of this index that is an index of the quality of your item pool. So this is basically what the whole presentation will be about. As an example, to show you what's going on, we've got some graphics here that show really what he's intending to do. If you look at the graphic on the right side, or left side, the examinee number 1, what you see, there's a couple of things here. A green line means the person got the item right, and so the ability estimate goes up. A red line means the person got an item wrong, and the ability estimate goes down. If you look really closely at this, you can see B's there, and those are the B parameters for the items that were administered to the person. And if you look at examinee number 1, you see that the B parameter is very close to the dot that's there, which is the ability estimate that they have after each item. And so in this case, examinee number 1 has a really, really good match between the difficulty of the items that are administered and the current ability estimate that they have. And so this is what you would say is a wonderful relationship between the item pool characteristics and that particular examinee. The one on the left, on the right, examinee number 2, this one you can see there's the person started out at 0, got a bunch of items right, and then missed a few, and then after that, but you can see those B's are trailing down away from where the ability estimates are. And what this is that this person is a high-performing person, and the item pool is too easy, and so there aren't enough difficult items in the item pool to administer to this person. So it's running out of difficult items as you go along, and the items that are being administered are progressively easier and easier and easier as you're going through this. So this is an example of poor match between the ability estimates that you get and the characteristics of the item pool that are available. So this is the thing he's trying to be able to detect statistically. So in an ideal item pool, he's got some quotes here that we say there should be sufficient number of high quality items that are targeted to the examinee populations. This is just what we're trying to get. They need to meet the content specifications, and they need to provide sufficient information at all levels of ability for the target population. So in the example that was just there, one examinee was well targeted, had all the items necessary for good estimation. The other examinee was a high ability, and the pool was too easy, and they were running out of good items. So he's trying to go over and create an index that shows, how good the item pool is relative to the population of examinees. Now, in the research literature, there's nothing out there that really says, here's a index of the quality of an item pool. Now, there are a lot of things that are out there. People do show the information function for the full item pool. They'll show conditional standard errors for ability estimates for people that have different levels of ability. They show a lot of things that are about the operation of the adaptive test, but a lot of these things have to do with evaluating the algorithm, evaluating a lot of other pieces besides the item pool itself. So what he's going to try, and what he's done, is he wants to be able to come up with a nice statistical indicator of how good the item pool is relative to the population of examinees. So we'll get right into it. This is his index, the Item Pool Utilization Index. And it looks a little bit imposing because of the symbols that he's got there, but the theta hat K-1 is your current estimate of theta after administering K-1 items. And that's the estimate that you're going to be using to pick the kth item. So that's the I there is the information from the item that is picked, the kth item, at theta K-1. Below that, you see something that says I max. And what I max is what the information would be if you had a perfectly matched item. So if you had the item that you really wanted for that person, and if that was available, that would be the information that you would get from that item instead of the information that you got from the one you actually administered. Now, so you're getting a ratio here. If you pick the perfect item to match that person, the ratio will be 1. But if you're having to give an item that is further away from the one that you want, you're losing information, and this ratio over here will get, smaller and smaller depending upon how far away you happen to get. Now, what he's doing is summing these things over all the items that a person's being administered and then averaging it, so you get an average indicator of how far off the items that were actually administered are from the items that would be give the maximum information for that particular person. So, and K is the test length. So as you go through this, you go and you actually get an indicator for each item administration plus averaging over all the items, and so then you can get something for the full test for a particular person. Now I can also take and then aggregate this over people, so you can take the individual person's index of utilization, and then however many people you have in your sample, you can go over and average those to get an overall indication of how good the item pool was for the full sample of people that you've administered this set of items to. Now, as I say, here's the example we just showed a little while ago. This is simulating the case where the item pool is too easy for this particular examinee. The dotted dashed line across there is actually the person's true ability in the simulation, so that's at about 1.5. And down in the bottom you see the index value, the IPUI index value for this particular examinee for this administration of the test is 0.56, I think. 0.561. And he's also got the standard error of measurement for that particular item, 1 over the square root of the information function, and it's 0.41. And one of the reasons for showing both of those is that later on we'll have an argument to say that the standard error of measurement by itself is not as good as using this kind of an index to show how good the item pool is. Now over here, this is an actual example of the computation of this index. Now what you see is you've got a column over there which is called Imax, and that's all 0.722. Now this was the simulation using the Roche model, and it had the scaling constant D equal 1.7 in the model when it was being done, so that's why the maximum information for an item is 0.722 for every item that's being administered. The column to the left of it is the actual amount of information that was obtained at the current estimate for the item that was administered. So if you look at the very first item at the top, you'll see that the initial estimate for this adaptive test, the starting point was 0. The actual item that was administered had a B parameter of 0.001, so it was very much targeted perfectly. So the amount of information you get from that item was 0.722, the max was 0.722, so the statistic for that particular administration, that one item, is 1. It's actually rounded to 1, it would be 0.999 something. So it's showing that first one was perfectly matched. The second item, you now have an ability estimate of 1.418, but the best item that it could find in the item pool was 1.339. So it's a little bit off, so its max the information for that item was 0.719, that's the amount actually obtained at the current estimate, compared to the 0.722, and you see the next index for that one administration is 0.995, and then in the last column is the average between the two of them. So the average drops a little bit to 0.998 because of this little difference. And as you go through this is a 15-item test, and you can see that down towards the bottom, there's a big difference between, like item 15, the ability estimate down there is 2.185, but the item that is picked, the best one it could find in the item pool through their item selection algorithm, in this case maximum information, is 0.248. And so now the ratio that you're getting for that one, the IPUI for the particular item administration is only 0.138. And then when you average that whole column there, you get the 0.561. So this is basically the index that he's recommending to go over and check and see how well the items that are administered are matched to the ones that you would want to administer if you had an absolutely perfect, wonderful, infinite item pool. So where all the items are there that you would like. Okay, now this index that he's got, it ranges between 0 and 1. So, 1 would be that you always had the perfect match to what you were after. And then a 0 would mean that your item was so far away it was giving you no information. I don't think in looking at the data that he's analyzed, you never really get down to 0 because the information function will always have some positive value, unless, I don't know, you'd have to get 6 standard deviations away or something. So, it really, that 0 is a hard lower bound, but in practical sense, it doesn't get down that low. So you can get this value for, this is a sample-specific kind of statistic because it depends upon the sample of examinees and the item pool that you have. So you could have an item pool that had a really good index when you had a sample of examinees that were matched to it. But if you took the same item pool and then administered it to a different sample of examinees, let's say ones that's a lot higher ability, then you could find that this item pool is not well matched to it. So this is a sample-dependent thing. The other nice thing about it is you can get the statistic by item, by person, by a group of people, and you can go over and get useful information out of all these different ways of looking at it. Okay, so now what he recommends actually is how to use this. So first of all, you could use this just as an absolute measure of how good is the fit between the item pool that you have and your sample of examinees and what the administration procedures are. So you can get this number between 0 and 1. Right now, I think that there's not enough experience with it to go over and say, oh, you should have a value that's above 0.9 or something. But I think he's working on getting more data with real tests to go over and check this out. I'll give you one example later on to give you some sense of this. But you could also compare different item pools. You could say if I took this group of examinees, use this item pool with them, and had another group of another item pool, and then go and see which one gave you the higher index to say which item pool is better matched to the examinee population that you have. You can also go over and look for weak spots in the item pool. If you looked conditionally on theta levels and saw what the IPUI value was for people who were at that theta level, like the example that we had up here for a high ability person, you could say, well, the item pool is working pretty well for this whole range, but for people when they're outside of this range, this value starts dropping off because you don't have any items that are the right level of difficulty to match up to the person. And then the last one, you can guide test developers once you get used to this is saying, well, what we want to do is have this index be in this range, between -2 and +2, and then we'll be really happy with the item pool that we have. So you can use this as a target for item pool development. So he's got all these ideas about how to go over and use this. Okay, now he wanted to really emphasize the difference between standard error of measurement, which is another thing that people show, and this index. So the examinee 3 over here, this is another really high ability examinee, and you're seeing here that this IPUI is 0.98. It's really high because those B's that you see in this diagram, you can almost not see them, they're in blue, are matched up to the points. And and the standard error is going down. It's 0.685 when the test is done. Now, it's actually fairly high because this never really converges to ability after the 8 items that have been administered. So it's still got a high standard error. The other example that's over on the right-hand side, examinee 4, has a really low, terrible index value, 0.273, because all the B's, this is a low ability person, all the B's are too high for that person, but the standard error is actually better than the one on the left. So it's the point being that the standard error measurement and this index are not correlated. They're actually correlated around 0.6, but they're not the same thing. So he's trying to make an argument to say this does give you unique information that you don't get out of other statistics. Okay, and I see I've got my 5 minutes left. Now you can generalize this to other models besides the Roche model, 2-parameter, 3-parameter, partial credit model. But when you do that, what you have to do is you have to set your sort of expected high value for the A parameter, because if you said what's the perfect item would have an infinite A, and you'd get infinite information, and then this whole breaks down. But with practical experience, you can say in my real item pools, I usually have items that have A parameters that are at a particular level, or below that, and you can use that level to go over and specify the statistic. So you need to have that in there to go over and specify the Imax that you're using when you're creating these ratios. But it is generalizable, and he's working on that right now. So maybe if we can get him to come to the next meeting, maybe he'll have that all done. And so he's just talking about the issue of infinite information and et cetera. Now, he's still making this argument that there's no perfect items, and you want to go and actually show this. Now, he didn't, for some reason or other, when he put these slides together and sent them to me, he didn't put in a real example. So I have all of his data and everything else, so I've looked up a real example. And this was actually on the NCLEX exam that I talked about, I think it was yesterday. It seems like it's a year ago. But it's, and he had applied this to the NCLEX exam. And that one, yesterday I talked about it. It has a huge item pool. It has 1,600 items in the pool. And it's a long test. And so it does very well. In terms of the statistics I was reporting the other day, this is a really, really excellent test. But I looked at it at the extremes. This is a test that's designed to make decisions. And so the decision, and once it makes a decision point, it stops. It's a variable length cat. And so at the extremes, up at around 2.8 and at minus 2.8, the IPUI for people at that level is around 0.7. So it's down, and that means that the amount of information you're getting for those examinees is about 70% of what the maximum could be if you had a better matched item pool. Now in this case, it's not a bad news thing because all the decisions are made very close to zero in the middle of the pool, and to keep the test length down and to save money so that you don't want to go over and create huge amounts of items over at +3 and -3, because that's not where the decisions are being made. And people, once they pass, they just get a pass, and it doesn't give them a score. So that actually doesn't make any difference, but it does give a context for what kind of values you would have if you don't have a good match to the item pool. Get values down around 0.7 or so. So anyway, this is what he's recommending, and this is his reference list, and questions and comments. Now I don't know if my timekeeper down here about how much time I've got. 2 minutes. So if anybody has a question that I can answer in 2 minutes. Otherwise, well, if we have time at the end, you can open it up for questions for everybody. Yeah. Okay, the question was, why does not the standard error and this ratio of informations come up with different meanings? And the reason is actually because you can have a very good match with items, but not get to convergence, so that you don't have enough items administered at the person's final ability estimate to get the standard error low, but you still have been administering the right items all the way along the way. It just means that you needed a longer test. Whereas opposed to, you could have a lot of mismatch, but you've got a lot of items near where the person was, and so the standard error can get smaller. So as I say, they're correlated, but they're not really highly correlated. So they are giving you slightly different information. One is a match to the desired item. The other one is how well you got to convergence in the adaptive test to get a good estimate at the end. Okay, well, I've got 3 more of these papers here, so at this point, I'll become the timekeeper. And if you have questions at the end, I think we'll all be happy to answer them.